If I asked you what the largest thing in the universe is, you might say a galaxy or maybe a galaxy cluster. But some of the biggest structures in existence contain almost nothing at all. They're called cosmic voids, and they make up most of the volume of the observable universe. Some astronomers propose that the Milky Way lies near the center of the KBC void, a possible cosmic void about 2 billion light-years across, with around 20% less matter than average. If confirmed, it could help explain why the local universe appears to expand faster than expected. I know that sounds impossible. How can almost nothing become one of the largest structures in the cosmos? To answer that, we have to go back nearly 13.8 billion years. Shortly after the Big Bang, the universe was remarkably uniform, but tiny density fluctuations already existed. They were incredibly small, yet gravity had billions of years to amplify them. Where there was slightly more matter, gravity gradually pulled in even more. Those regions eventually became galaxies, galaxy clusters, and the enormous filaments that form what's known as the cosmic web. As matter was drawn toward these denser regions, the surrounding areas became increasingly underdense. Over billions of years, those underdense regions grew larger and became the cosmic voids we observe today. If we could zoom far enough away, the universe would look like a giant three-dimensional web. The bright strands are packed with galaxies. Between those strands are enormous regions where very little matter exists. Those are the cosmic voids. Most measure tens to hundreds of millions of light-years across. To put that into perspective, our Milky Way is about 100,000 light-years wide. Some voids are thousands of times larger than our entire galaxy. One of the most famous is the Boötes Void. It's roughly 330 million light-years across. Given its enormous size, astronomers expected far more galaxies than were actually observed. Instead, it contains only a small fraction of the galaxies found in an average region of the same size. One quick note, many images claim to show the Boötes Void actually depict Barnard 68, a nearby dark nebula, not the void itself. The Boötes Void isn't a giant black hole or dark cloud. It's a sparsely populated region of space, so there's no single photograph that shows it as a black circle. Calling these regions empty is still an exaggeration. They contain dark matter, extremely thin gas, radiation, and a small number of galaxies. The difference is density. Compared with the rest of the universe, there's simply much less matter there. Astronomers are especially interested in voids because they provide one of the cleanest environments for studying the universe. Without the complex gravitational environment found around massive galaxy clusters, researchers can better investigate how galaxies evolve, how matter is distributed across the cosmos, and how dark energy influences the universe's expansion. Every New Sky survey maps these voids in greater detail, helping scientists test some of the biggest ideas in modern cosmology. The universe isn't a solid wall of galaxies. It's a vast cosmic web with enormous regions of near emptiness stretching between its filaments. Ironically, some of the emptiest places in the universe are helping us answer some of its biggest questions. One of the surprising things about cosmic voids is that they don't just sit there doing nothing. They're actually expanding faster than the average universe around them. That might sound strange because the universe itself is expanding everywhere, but inside a void, there's less matter, which means there's less gravity pulling everything together. As the denser regions around the void continue attracting galaxies, the void becomes even emptier over time. In a sense, matter flows out of these regions toward the cosmic web, causing the voids to grow larger. This doesn't mean galaxies are being pushed away by some mysterious force inside the void. Instead, it's gravity doing what gravity has always done. Dense regions pull matter in, and as they do, the underdense regions are left behind, becoming larger and emptier. In fact, simulations of the universe show that this process naturally produces the sponge-like structure astronomers observe today. Starting from tiny fluctuations in the early universe, Billions of years of gravitational evolution create an intricate network of galaxy clusters, filaments, walls, and expanding voids. It's one of the greatest successes of modern cosmology because these simulations closely match what large galaxy surveys actually see. What's even more fascinating is that voids may be among the best places to test fundamental physics. Near massive galaxy clusters, gravity is incredibly complicated. Galaxies interact, merge, and experience powerful tidal forces. Inside a cosmic void, those effects are much weaker. That makes voids something like natural laboratories, allowing astronomers to test whether our theories of gravity remain accurate on the largest possible scales. Some alternative theories of gravity predict subtle differences in how voids expand or how galaxies move within them. By comparing precise observations with computer simulations, researchers can rule out some ideas while strengthening others. In other words, some of the emptiest regions in the universe could reveal whether our understanding of gravity itself is complete. Voids also help astronomers map something we can't even see directly: dark matter. Although dark matter emits no light, its gravity influences where galaxies form and how the cosmic web evolves. By studying the shapes, sizes, and distribution of cosmic voids, scientists can infer how dark matter is spread throughout the universe. Every new survey adds another piece to that puzzle. Looking far into the future, these voids are expected to become even more dominant. As the universe continues expanding, galaxy clusters will remain gravitationally bound, but the distances between those clusters will keep increasing. The cosmic web will gradually stretch, and the voids between its filaments will occupy an even greater fraction of the universe's volume. Trillions of years from now, the universe will be an even lonelier place than it is today. It's incredible to think that the largest structures in the universe aren't towering walls of galaxies or unimaginably massive objects. They're regions defined mostly by what isn't there. When we imagine exploring space, we usually picture dazzling galaxies, brilliant nebulae, or supermassive black holes. Yet the universe is mostly made up of enormous expanses where almost nothing exists at all. And somehow, by studying those vast stretches of near emptiness, we're learning more about gravity, dark matter, dark energy, and the history of the cosmos itself. Sometimes the biggest discoveries don't come from looking at what's there. They come from understanding the space in between. If you enjoyed exploring the universe with me, don't forget to like the video, subscribe for more journeys through space, and share this with someone who's curious about the cosmos.